Okay, kita sambung. So yesterday we have reached impulse momentum. Kamu dah review belum nota tu sampai habis? Dia bagi contoh-contoh lah apa jada-jada tu. Ke kau pun main tinggal Dah diam balik. Okay, so let's take a look a bit more on the calculation and then we go to the final topic which is summation of force. Okay, ni contoh yang pertama. This is talk about impulse. So let's say in a sprint start, the average horizontal force is 800 Newton and is applied for 0.27 second. Okay, here this three equation is actually quite straightforward, but the thing that I want to show you here is that based on the equation of impulse, based on this equation, we can prove that range of motion is important. Ni kita boleh provekan benda ni. Okay, for example, we have, let's take golfer. Let's take two golfer. Okay, so swinging action. Okay, so one golfer swing the club from here, contact. Okay, this is A. And another golfer able to swing the club from here, contact B. The difference here is that A daripada half daripada shoulder width, shoulder height tu dia swing. Let's take TA equals to 1.1 second and TB equals to 1.4 second. Okay, just a difference of 0.3 second. And if this golfer able to produce force at the hand region at, let's say, 500 Newton. Okay, 500 Newton. So now let's compare IA dengan IB. IA equals to 500 time with 1.1. IB equals to 500 time with 1.4. Okay, berapa kita dapat dua ni? 500 time 1.1, it would be 550 Newton per second. And as for the B is 500 time 1.4 equals to 700 Newton per second. Okay, ni baru impulse. Let's say the golf ball, the weight of this golf ball is 120 gram. Okay, kita cuba calculate dia punya momentum. Momentum A, momentum B. Okay, we try to find out how fast the ball travel. Okay, so momentum A equals to mv. So momentum A, kita ambil FA, ni IA, 550. Momentum B, 700. Okay, berat bola tadi 120 gram, which is 0.12 kg V. Same as here, 0.12 kg V. So V will be 550 divided with 0.12. This one will be 700 divided with 0.12. Okay, kita tengok A dulu. 550, 0.12. 454 ambil kau. Ni tak logik kan, tapi tak apalah, kita buat pengiraan kan. Meter per second. And as for B, bagi 0.12, kita ada 5833.3 meter per second. Okay, look here. The difference is just only 0.3 second. A, shoulder height. B, full ROM. With the same amount of force, it yield a different amount of impulse. And this proof by having a full ROM, it helps a lot, especially if you try to reach further, if you try to have a faster ball. Kat sini dia dah prove dah. And we further prove it by calculating the velocity of the ball. So we know that by having a difference of 0.3 second, we have a difference of 1000 meter per second. Roughly lah. We have roughly perbezaan hampir-hampir 1000 meter per second. This proves that ROM play a major role in determining the outcome of every single performance. Ni benda ni. Ni cara kita prove kan. How we want to prove ROM play the major role. Macam ni soalan direct je lah. If the question is something like this, average horizontal force 800 apply. So the question is actually, we have force 800 Newton that way being applied at 0.25 seconds. So the question is, what is the impulse? Straightforward. Aduh, calculator ni. I equals to FT. Ni soalan direct. 800 kali dengan 0.25. Berapa dapat?
200.
200 apa? Newton per second. Newton ni kan kadang-kadang kamu tak jumpa dia dalam bentuk N. Kamu jumpa dia dalam bentuk kgm. This is the same thing. N is equals to kgm. Jadi you can write it as 200 Newton per second or 200 kgm s. These two thing is equal. Newton is kgm. Okay, kg and m. Okay, ni unit je lah. Tapi kalau lupa sakit kepala, tengok je lah unit yang atas tu. Kalau F dia N, T dia S, and S lah unit dia. Alright, so that will be the first one. Is it true? Is it true? Lain je. Oh, 0.27. Okay, tak apa. Tadi kita 0.25. Okay, in running a vertical ground reaction force of 102,000 Newton act for about, what is the total impulse? Okay, in running a vertical GRF. Do you still remember what we have learned during first class? Force plate. Kan, bila kita kira force plate, dia boleh bagi you gambar macam ni. This is known as GRF, ground reaction force. And the question said that in running, a vertical GRF of 1,200 Newton acts for 0.2 second. So dia berlari, and setiap kali dia push to the ground, it yield a figures of 1,200 Newton. And every single step, it took 0.2 second. So what is the impulse? GRF is based on Newton's third law, is amount of force. And this amount of force is a reaction force. Nama part reaction force. Means the player or the runner give force to the ground 1,200 Newton, and the force bounce the player by 1,200 Newton. So soalan dia jadi direct lah. I equals to Ft, where the F will be 1,200 and the T will be 0.2. Ni soalan-soalan direct. Kita tengok laju je lah. Okay, 240. Alright, and then the third one, in a vertical jump ke atas, the average net force acting is 900 Newton. Okay, for 0.8 seconds. Still the same equation. It will be 720. Vertical jump means they impose 900 Newton down. They will get 900 Newton up. That will be impulse. Okay. Okay, this is momentum. Momentum kita dah settle ini. Okay, this one is impulse momentum theorem. We have done this one. Ini contoh dia. Impulse equals to change in momentum. What is the sprinter change in momentum and speed reach? Basically dia nak kita cari momentum je lah kat situ. Benda yang sama. Okay, ni semua adalah equation yang sama. Okay. This is what we have discussed. Ni GRF. Ni contoh ini. Okay, again the same question. Okay. The last topic is about principle of force summation. It come from a root words sum. Okay, ni sum, summation. Jadi, bila principle of summation of force means that when we try to conduct an action by adding up all the force, it can give much better outcome. Okay, so dia bagi dekat sini. Force is a force lah. Kita nak tengok konsep sum. To add, so how we want to add force? We try to kick the ball, and how we can actually give more force than we can have from the leg sahaja. Itu maksud summation of force. Okay, so force is the action, and force came from two different sources. It can be internal, it can be external. Okay, ni internal force. Internal force yang kamu kena faham is this one. Muscles. So most of the time, internal force is caused by contraction. Is caused by contraction. Kita sepak bola, we produce force at the hamstring and quadricep. When we kick the ball, ingat benda yang kita belajar semalam, impulse being transferred. That is an example of external force. Okay. Tu benda tu kena faham. Internal, external. Kita sepak bola. When your leg touch the ball, here you are going to get impulse. When you try to kick the ball, you need to have a backswing and a contact. This action caused by muscles contraction. This one is an example of internal force, means force that being produced internally. This one is known as external force, means that impulse, external force. It means that it is a type of force which you are going to have based on collision. Means it being transferred from one another to impulse. So impulse is external. Muscle contraction is internal. Okay, to asas dia. So what you try to have is actually to have a summation of internal force. Okay, how to do so? Okay, how to do so? Kita buat macam ni. Okay, this is some of the factor or some of the ways in order for you to get a summation of force. First, use as many body segment as possible. Okay, kalau kita nak sepak bola tadi, let's say we want to kick a ball. Okay, macam mana kita nak jadikan apa kaki dia ni terbalik? Macam mana kita nak jadikan dia menggunakan seberapa banyak body parts yang possible? You want to kick a ball, you are going to use right leg, example lah. Okay, right leg. But how we want to incorporate more than right leg? Itu summation of force. Okay, how we want to incorporate more than right leg? Basically, you can increase the amount of force by having a run up. So nak run up, you akan ada apa? You akan involve both leg. You akan involve COG, means body weight, more body parts. That is the first one. Involve more body parts. Number two, movement must be in correct sequence. Use the large muscle and then follow by small one. Okay, nak lari tadi, kita pakai masa besar. Nak sepak, kita still pakai masa besar. sampailah kita nak control accuracy, and then only kita akan control your feet. Okay, and then this movement need to be in sequence. Ada sebut correct timing. Okay, correct timing, sequence and correct timing means if you try to kick with your right leg, okay, if you try to kick with your right leg, you need to have a run up, and this run up need to be able to make you, okay, katalah ni bola, stop here by your left leg, and then only you can have your swing back and contact, follow through. Cuba bayangkan kamu lari, ni bola, kaki kanan dah berhenti kat sini dah. How can you kick the ball with your right leg? You kena berhenti, you kena mula balik, swing back, and then contact, follow through. So when you have a stop or a pause where the continuation is not there, ni benda ni tak ada. Timing tak ada. So the force that being bring from the start of that running, dia akan putus. You are not going to get any summation of force. Instead, you're just getting your force from the leg only. Dah tak dapat dah semua segmen tadi. Okay, correct timing. And finally, movement must be through the greatest range of motion, not a limited ROM. This is what we have learned here. Mana? Sini. Okay, by having full ROM, which take a difference of 0.3 second, we can increase the amount of force by 1,000. Tu adalah konsep summation of force. Macam kita nak buat free apa ni? Sekejap kita nak buat free throw dekat dalam basketball. Example. Basketball free throw. Okay. Okay, kita tengok dia punya action tu. Sekejap, tengok pada tepi. Sagittal is the best for this one. Alright. If you want to do a free throw, just a simple free throw, you don't need to bend your knee. Boleh je berdiri tegak and then throw. But, if you want to apply a principle of force summation, this is one of the way. So, you are going to harness a force from the feet upwards, not just only relying on your force being generated by the hand. Kita boleh nampak dia punya pergerakan. There are counter movement jump where they are going to bend down and they are going to use the spring action. So when we propose a spring action, there's a amount of force that will be delivered and it will be transferred. Kalau kita tengok ni kan, can we go slow here, playback speed. Okay, if we take a look here, okay, now let's start from here. Okay, from quite a bending position, and you're going to notice that he will bend down a little bit. About dia turun lagi. They need to harness more flicking action, and then the force, okay, instead of just using force being generated by the hand, they harness the force from the jumping, and finally towards the end is flicking of the wrist. Last sekali, to throw the ball forward. So it use less effort. Satu. Yang kedua, it prolong the time. Okay, banding dengan dia berdiri tegak, throw, with a lot of movement and then throw, the time being prolonged with the same amount of force, benda yang kita proofkan tadi. It increase the output based on increase of impulse. Itu adalah principle of force summation. Okay, jadi bukanlah semestinya apa ni, basketball saja. Ni contoh macam basketball. Sukan-sukan lain pun kebanyakan where the force is the outcome of everything, we actually conduct summation of force. Okay, contoh macam ni dia bagi um, pictures. Cuba bayangkan pictures ni, dia tak ada pun buat daripada nombor 1 sampai nombor 6. Dia pergi nombor 6 je, pergi situ balik, zas. Yes, the ball is going to move forward, but the amount of force, the amount of momentum that the ball have is going to be less and less. Simply because the impulse is not enough. So how we want to increase the impulse? Use summation of force. Salah satu cara dia. Force kita dah maksimum ni, dah tak boleh naik lagi. And then you prolong the contact time. So, you are going to increase the impulse production. Salah satu cara is this one lah. Contoh macam ni. Jadi, dia gunakan one, we are going to see they are stepping. Okay, they are stepping. But, the thing that being used here is actually body weight. Dia gunakan momentum badan dia in order to make the throw even faster. And then they go a full ROM throw. Instead of just go above the shoulder and throw, so dia mula daripada waist. And then they are going to have rotation. That rotation will increase the time before release. It will increase the impulse. Ni adalah konsep summation of force. Contoh macam inilah dia bagi. So large body, step forward, and then rotation hip. Every single movement here produce velocity. When you increase the velocity, you are going to increase the momentum. Okay, M equals to mv. Increase momentum, increase velocity. Increase velocity, increase momentum. When you increase momentum, automatically the impulse is going to increase. Jadi, bila dia lepas, that is the highest amount of impulse possible. Okay, so the outcome will be much better. Flaws dekat sini boleh jadi disebabkan dua je. There may be flaws, and these flaws caused by two things. Satu, incorrect sequence. Okay, incorrect sequence and incorrect timing. Sepatutnya dekat sini you dah roll, kamu belum roll. So you take more time. The sequence will cost you. So in order to get a good sequence and timing, you need practice how to execute the skill as fluent as possible, because when you have a fluent skill execution, you are going to be called as energy efficient athletes. Means that you use less force in order to get a greater outcome. So if you invest more force towards the system, you are going to get much better compared to others. Ni adalah principle force summation. Okay, ni timing. Each part must develop maximum velocity. They talk about velocity, means that movement. The more velocity you have, the more momentum. Momentum translate to impulse. Okay, the smaller body part which are lighter and can move with the greatest velocity should complete the action. Okay, itu adalah principle of force summation. Okay, itu sahaja untuk topik kita pada minggu ini, which is regarding Newton law, impulse, momentum, and also force summation. So force summation ni macam mana kita cakap, dia ni konsep. Okay, dia ni konsep. We don't have any calculation to prove it, to prove it, but this is actually concept. If you try to prove force summation, you may consult with impulse momentum theorem. Okay, benda yang kita bincang semalam. Everything that being given an external force will have impulse. Impulse will cause movement. Movement will transfer force, will transfer impulse to another contact. So in human motion pun, every single part yang kita buat, it will cause movement. And when we talk about movement, means we can quantify that in terms of momentum. And when we have momentum, we have impulse. So by having a good ROM towards all body parts, means everything will be accelerated to a certain point. This one. Okay, everything will be accelerated to a certain point. And summation of all of this movement will give you the peak amount of impulse possible by that particular technique. Okay, itu sahaja. Do you have any question? Ada soalan tentang principle of force summation?
Tak ada, sir.
Okay, kalau tak ada, Sekejap, kita cuba tengok ada tak contoh. Force summation, biomechanics.
My essay written, and I've been working on it for about a week. So now I'm going to show you how I use Grammarly to edit.
Lah ini. Oh.
Hello everybody, my name's Paul Stockdale from ABCPE.
Salah, benda yang sama dia cerita tu, summation of momentum. Kalau kita susah nak faham force summation, kita cerita summation of momentum. Means we sum up all the movement. Force summation is impulse summation lah. So, cerita impulse, cerita momentum, benda yang sama.
Where we try and make VCE-PE as easy as ABC. Today I'd like to talk to you about force summation, or another word for it is summation of momentum. Basically, we use summation of momentum or force summation whenever we try and throw, kick, hit an object as far as we possibly can. We try and use as many body parts as possible to send the projectile as far as possible by making sure that it's at maximum velocity when we release it. One thing to keep in mind here as we go through is that momentum is mass times velocity. I will come back to that point shortly. So for maximum force, there are 4 things that I need you to remember when we're summating forces. The first and possibly most important is that we want to try and use as many body parts as we possibly can. The second is we want to move those body parts in sequence. I often tell my students that we throw with our legs and they think I'm really silly. Well, we do throw with our legs because they are the stronger muscles. And what we want to try and do is have a sequence where we use the stronger muscles or body parts that are heavier but slower. Remember, mass times velocity. And then we start to bring in body parts that are smaller, weaker, lighter, but faster, such as the body parts of the arm and the wrist and the fingers. And the fastest body part needs to be the part that touches the ball at the last moment so that the ball flies off at the fastest velocity. So timing is important here. So if we start with the legs and we move to the trunk and then we move to the shoulders, we finally get to the wrist, what we want to be doing is making sure that we move the next body part when the previous body part reaches maximal velocity.
Okay.
Pretty simple.
Saya nak kamu tengok graf ni.
The next.
Okay, and then take a look at point number 4. This is as similar as the example that I give. If the timing and sequence is not correct, and then you are not going to get the maximum momentum since you need to start again and again. Dia tak ada continuation. Okay, when we talk about stabilization, we need to have continuation, so that the movement is going to be one fluid movement, so we can transfer force from one to another. And always remember, when we transfer force, it keep on increasing. Dia bukan makin turun ke bawah. Dia boleh jadi makin turun simply because sequence dia tak ada, dia putus. Action tu tersangkut-sangkut, so you are going to start again. But if we transfer the force, it going to be increasing. Ini adalah point keempat dia.
Next body part when the previous body part reaches maximal velocity. And then finally, in order to pass all of that momentum on and so it doesn't get lost, we have to stabilize the body parts. So as we move the momentum from one body part to the next, that previous body part stabilizes. Here's a video I've made to help explain the force summation concept. I hope it helps. Okay, I'm going to demonstrate now force summation, but I'm going to do it in the opposite way. That is, I'm going to start with the lightest and the fastest body parts first. And you'll see that I won't get very far, but as I introduce more body parts, I should be able to throw the ball further. Let's have a look. First body part is my wrist only. The next one is elbow and wrist, and you can see I get a little bit further with the ball. Now I introduce the shoulder, elbow and wrist. This time I'll include my trunk. So I'm starting to get those bigger, stronger muscles that weigh more but travel a little bit slower. Now let's include the legs. It is I'll step forward, then followed by the hips, the trunk, the shoulder, the elbow, the wrist and the fingers. And that should give me some good distance. And the final one, run up, full momentum, nice sequence, nice timing, good throwing. That's force summation. Too many exam questions from VCAR on this, but I was able to muster up a question.
Okay. So, do you have any idea about force summation? Dia bagi contoh satu persatu tadi. We start with wrist, and then you go with elbow, the full hand, and then the body. And afterwards, they have one step, and then they have a run up before the throw. So we can see that the distance covered by the ball is going to increase phase by phase simply because the amount of momentum throughout the motion is increasing, which resulting more impulse being transferred to the ball and cause the ball to travel further. Itulah konsep force summation. Okay, soalan? Tak ada? Diam. Halo?
Tak ada.
Baik.
Tak ada rasa.
Okay, simple konsep dia simple je. But that is the concept of force summation. Ingat je 4 point tu. Use most body part as possible. And then point number 2, you need to have use large muscle and then only move towards the smaller one. Number 3, correct timing and sequence. And number 4, stabilize. 4 point untuk have a good force summation. Okay, so if you don't have any question, this will serve as the end of our class.